Good morning. Sensors and actuator devices. In this subject, we are going to discuss about signal conditioning of sensor signals. In electronics, signal conditioning means manipulating an analog signal to such a way that it has to meet the next stage for further processing. So most commonly we will do analog to digital conversion, and also majorly the signal conditioning consists of three blocks: sensing element, signal conditioning element and signal processing element. Signal conditioning element is the first stage. It converts the non-electrical signal to electrical form. That means it converts any form of signal into electrical form. Second stage is signal conditioning. Here we are going to convert the electrical signal into voltage level suitable for next processing. And the third stage is signal processing. Here we are going to convert the electrical signal into suitable for the presentation. That means for display, recording, feedback control, like that. So in the diagram we can see this. The input is given here. Sensing element converts a non-electrical signal to electrical signal. Then signal conditioning, it is converts electrical signals into the required voltage form that will be processed for next stage. The signal processing element, it makes the signal to be ready for the next display, like the display or recording. So the elements of the measuring system consist of the signal conditioning circuits. Here various functions done by the signal conditioning circuits are filtering, amplifying, isolation, amplification, linearization and attenuation. So why we need the signal conditioning? Signal conditioning is it's need to be amplified because the many signals from the sensors are too small, so we have to amplify. For example, biosignals are not very small, so it will be in the microvolts, so we have to be amplified. Next, it may contain the interferences, we have to remove it. The third one is it have a non-linear properties, so we have to make it as a linearization. Sometimes the signals may be analog, so we have to convert as a digital. Suppose some digital signals is need to be converted as a analog. And another thing is resistance change. It has to be made into a current change or voltage change. That means we have to convert this voltage into a required current form. So like this, we have to convert the signal into the required format. For this, we need a signal conditioning. Here we consider one of the application, thermocouple. So we need a signal conditioning for thermocouple circuit because thermocouple output is low. Thermocouple output is a small voltage, that's why we need a signal conditioning. So it is we are going to convert into a suitable size of current signal, and also it provides noise rejection, linearization and cold junction compensations. All these things done by the signal conditioning module. We see that this is a thermocouple, a simple thermocouple without signal conditioning. We can see this two metal wires, metal 1, metal 2 will be connected here. This junction, it forms a thermocouple. This is the cold junction and the hot junction. So here in this thermocouple, we are going to connect with this signal conditioning circuit. The same, that is a thermocouple circuit, we are going to connect with the signal conditioning. The signal conditioning consists of amplifier and ADC to display. So the amplifier, it amplifies the low input of the thermocouple to high. Then this analog to digital converter, it converts analog signal into digital signal to display. So this is what the thermocouple needs the signal conditioning here. And also because of this signal conditioning, it provides protections. It avoids the damage because it resists the current limiting and fuses polarity. Everything it will be limited, and it helps to get the right type of signals, and it gets the right level of signals, and it eliminates or reduces the noise level, and it manipulates the signals. So this is what the signal conditioning of the thermocouple helps to produce the signal to the next level. Thank you.